Have you ever thought about how companies and governments manage and analyze huge amount of data to create powerful maps that reveal hidden patterns and insights? Enter the world of Geographic Information System, also known as GIS. Maps are brought to life through driven data analysis, unlocking a treasure trove of information that goes beyond what meets the eye. But what challenges lie in harnessing this technology? How can we overcome them to unlock the full potential of GIS? Join me as we navigate through the complexities and possibilities of GIS, bridging the gap between the geography and the technology. In today's presentation, we will define what GIS is and why is it so important, and also we'll explore some real-world projects that use GIS, and in the end, we will see some GIS innovations. But first, let me introduce myself. This is Nohan Ashraf Abubak. I am graduated from Faculty of Petroleum Engineering from Cairo University 2021 and currently working as a technical planner and scimitar production agent. So let's start by defining what GIS is. GIS stands for Geographic Information System. It's a computer-based tool used to map and analyze spatial data. It allows users to visualize, question, and interpret data to understand relationships, patterns, and trends. GIS also has revolutionized environmental monitoring, land use planning, and natural resource management. And as we mentioned, this presentation will explore the power and the potential of GIS technology in these fields. Why the GIS is so important in environmental monitoring and natural resource management? Hundreds of thousands of organizations in virtually every field are using GIS to make maps that communicate, perform analysis, and share information, and also resolve complex problems around the world. This is changing the way the world works. One of the key reasons why GIS is so important in environmental monitoring is its ability to integrate various types of data from different sources by combining satellite imagery, aerial photographs, topographic maps, and field survey data. GIS enables us to create comprehensive and accurate representation of the environment. This spatial data integration allows us to identify patterns, detect changes over time, and assess the impact of human activities on natural resources. Furthermore, GIS provides powerful analytical tools that can help us better understand complex environmental processes. By overlaying different layers of data and performing spatial analysis, we can identify areas prone to erosion, predict the spread of a pollutant, and model the impact of climate changes, and much more. This spatial analysis capability of GIS not only improves our understanding of the environment, but also helps us to develop effective strategies for its management and conservation. Moreover, GIS plays a crucial role in supporting decision-making processes related to land use planning and natural resource management. By providing visual representations of data through maps and interactive dashboards, GIS facilitates communication and collaboration among stakeholders. This allows policymakers, scientists, and the public have a common understanding of environmental issues and ensures that decisions are based on accurate and up-to-date information. And now, after we knew how important the GIS is, let's see where can it be used. So it can be used in environmental monitoring and land use planning, and also in many various fields. GIS is instrumental in managing water resources, especially in areas prone to water scarcity and pollution. By integration data of rainfall, river flows, groundwater levels, and water quality, GIS allows for the identification of water stress areas, the monitoring of water availability, and the assessment of the impact of human activities on water quality. This information allows policymakers to develop effective water management strategies and prioritize conservation efforts. Also, GIS is a valuable tool for biodiversity conservation by enabling the identification of critical habitats and mapping of species distributions. By analyzing data on species richness and habitat fragmentation, GIS helps prioritize and design conservation areas. This leads to more targeted and efficient conservation efforts, ensuring the preservation of biodiversity for future generations. Also, GIS plays a crucial role in land use planning by providing a spatial framework for decision making by integrating data on land cover, soil types, topography, and infrastructures. GIS enables land managers to identify suitable areas for agriculture, forestry, urban development, and conservation. This helps optimize resource allocation, minimize conflicts, and ensure the long-term sustainability of land use practices. Also, GIS can be used in various fields, such as education, health, insurance, manufacturing, and more. In the education field, GIS improves teaching, learning, research, and administration. In the health field, GIS helps understanding the impact of place leads to better health. Also can be used in manufacturing, insurance to gain hyperlocal risk insights, and in the petroleum field, of course, to support the entire energy value chain with GIS, and in the public safety to keep communicates safe with real-time GIS technology and solutions, and in the real estate field to leverage the power of location analytics, and also in the retail, as retailers demand precise location intelligence for sustainable growth, and last but not least, in the telecommunications field, and so much more. While GIS have revolutionized the way we analyze and visualize spatial data, they are not without their challenges. Here are a few areas where GIS can be challenging. First, the data quality and accuracy. GIS relies heavily on accurate and high-quality data. Obtaining reliable data can be challenged due to outdated or incomplete information, errors, or inconsistencies in data collection methods. Also, in the data integration. Integrating data from various sources and formats can be complicated. Different data formats, coordinate systems, and scales need to be aligned and transformed to ensure compatibility and consistency. GIS deals with large volume of spatial data, including raster and vector datasets. Managing and storing such massive amount of data can be challenging, requires powerful hardware and efficient database management system. Also can be challenging in the spatial analysis complexity. Conducting complex spatial analysis requires in-depth knowledge of GIS tools, methodologies, and programming languages. Understanding statistical concepts and choosing appropriate analysis techniques can be challenging for non-experts. Also in the technological advances, GIS technology is constantly evolving. Keeping up with the latest software updates, new tools, and techniques can be overwhelming. It requires continuous learning and training to stay abreast of technological advancements. Cost and resources of the GIS also can be challenging. Implementing and maintaining the GIS system can be costly. Organizations need to invest in hardware, software, license, data acquisition, and skilled personnel. Additionally, ensuring regular updates, data maintenance, and user support to add the overall cost. However, it's important to note that the long-term benefits of GIS often outweigh the initial investment by providing accurate and up-to-date spatial information. GIS helps optimize resource allocation, reduce operational costs, and improve decision-making processes. One of the most challenges that is very sensitive regarding the GIS technology, the privacy and security. Spatial data often contains sensitive information such as personal addresses or confidential business data. Ensuring data privacy, implementing access controls, and protecting against unauthorized use or data breaches are critical challenges in GIS. GIS usage must comply with the legal and ethical guidelines. Issues such as data ownership, copyright infringement, privacy regulation, and potential bias in data analysis need to be carefully addressed. But despite these challenges, GIS continues to be a powerful tool in various fields, including urban planning, environmental management, transportation, and emergency response. With proper planning, data management, and expertise, many of these challenges can be overcome to harness the full potential of GIS. And now, let's explore together some examples of successful GIS projects in environmental monitoring and natural resource management. The application of GIS in environmental monitoring and natural resource management has led to numerous successful projects worldwide. Here are a few notable examples. The European Space Agency employs GIS to monitor air quality and track the impact of air pollution to human health. By combining satellite imagery, ground-based monitoring stations, and population data, GIS helps identify areas with high pollution levels, assess the effectiveness of emission reduction measures, and inform public health policies. Another example of GIS project is the Great Barrier Reef Marine Park Authority in Australia. It uses the GIS to monitor the health of the world's largest coral reef system. By combining satellite imagery, water quality data, and field surveys, GIS helps identify areas at risk of coral bleaching, track the spread of invasive species, and monitor the effectiveness of conservation methods. Also, another example is the Forest Inventory and Analysis Program in the United States. It utilizes GIS to assess the health and productivity of forests across the country by integrating remote sensing data, tree species inventories, and ecological modeling. GIS enables forest managers to identify areas susceptible to wildfires, manage biodiversity, and plan sustainable timber harvesting. One of the most impressive GIS projects is the African Elephant Database. This project uses GIS technology to track the population and movement of African elephants across the continent. The database collects data from a variety of sources, including area surveys and GPS tracking devices attached to the elephants. This data is then analyzed using the GIS technology to create maps of elephant populations and to identify areas that are particularly important for conservation. The African Elephant Database is the largest online elephant database in the world and also possibly the largest database of individual animal records. These examples demonstrate the power of GIS in addressing complex environmental challenges and supporting evidence-based decision-making. As GIS technologies continue to advance, we can expect even more innovative applications in the future. How innovative the GIS can be. As technology evolves, new and innovative GIS technologies are emerging, further revolutionizing environmental monitoring and natural resource management. Here are a few noteworthy advancements. First one is the remote sensing and LiDAR. Remote sensing techniques such as satellite imagery and aerial photography have become increasingly accessible and affordable. Combined with the light detection and ranging LiDAR technology, which uses the laser pulses to measure distances, these tools provide highly detailed and accurate data of environmental monitoring, and they enable the identification of land cover changes, the mapping of vegetation density, and the monitoring of coastal erosion. The second innovation of GIS is the mobile GIS and field data collection. With the advent of mobile devices and GPS technology, field data collection has become more efficient and accurate. Mobile GIS applications allow researchers and field workers to collect geospatial data directly in the field, eliminating the need for manual data entry and reducing the risk of errors. Real-time data collection and integration with GIS databases enables timely decision-making and faster response to environmental emergencies. Another innovation is the big data and cloud computing. The increasing availability of big data and cloud computing has transformed the way GIS operates. The ability to process and analyze massive volumes of data in real time allows for more comprehensive and up-to-date environmental monitoring. Cloud-based GIS platforms enable collaboration and data sharing among multiple users, making it easier to access and disseminate information across organizations and regions. These innovative GIS technologies not only enhance the accuracy and efficiency of environmental monitoring, but also open up new possibilities for data analysis and modeling. By leveraging these advancements, we can gain deeper insights into the environment and develop more effective strategies for its management and conservation. In the end, GIS technology has the power to transform environmental monitoring, land use planning, and natural resource management by collecting, analyzing, and visualizing spatial data. GIS can help us make informed decisions and protect our planet and its resources. And that will be all for today. Thank you for watching, and this is Nourhan Ashraf. Hope you enjoyed the presentation. Goodbye.